Right. We have studied what basically rule-based systems are, the various terminologies, particularly rules themselves. Now let's look at the structure of a typical rule-based system or expert system. It has a knowledge base, a database, something called inference engine, an explanation subsystem, user interface, and a knowledge engineer interface. The first two relate to knowledge. Knowledge base and database is the essential knowledge, right? You know, those numbers that we initially talk about, the representation in tabular form, relational databases. Knowledge base is a higher level knowledge. No? Several times I've mentioned that typically represented in the form of rules based on basic knowledge and experiential knowledge. Inference engine is that the sometimes called the compiler for that. Inference engine uses rules to infer new information, explanation, how it works, how it came to a conclusion or a solution. A user interface, and of course, a knowledge engineer is the person who's building that system. So you need to have an interface for that. There are basically two types of inferences, deduction systems. One is called the forward chaining system. The other is called a backward chaining system. So let's start with the forward chaining system. You are given a certain set of facts in the memory, and we use the term called working memory. Why do we use the word working memory? It's because that is only temporary. That is, as long as, in the case of, let's say, a medical doctor, a patient comes to the doctor, so he or she has got some pre-built knowledge about medical domain, right? And then here comes the patient. So those facts that relate to that particular patient are temporary and are really in the working memory, the current memory of that expert. Okay, and these keep changing. When the next patient comes in, the working memory will be kind of erased, and we'll start afresh, named or data of that patient as well. So that's the working memory. So given a set of facts in the working memory, okay, use the rules in forward chaining to generate new facts until the desired goal is reached, or a new conclusion or a conclusion is reached. Typically, going to discuss an algorithm which is used in implementation of these systems, and that's called the Reti algorithm. The Reti algorithm, okay, pretty straightforward as such. Following steps are kind of followed in this Reti algorithm. First of all, match the if part of each and every rule against the facts in the working memory. So that's the matching part. So remember, as I said several times, there are the if side of rules. So there are, let's say, 10 rules, all right? Now, each of them have their if sides. Match them against the facts in the working memory. Now, if there are more than one rules whose left-hand side, the if conditions match with the facts, then we need to select one of the rules to apply. Okay, and applying a rule is like executing a rule, firing a rule, right? So you need to select from, if there are more than one that are matching with the facts, and that's something called a conflict resolution. So what is conflict resolution? Happens in everyday life as well. You have various choices that come across, right? And then you need to define, I have a certain priority, somebody else has a different priority, or I'm going on a road, and I need to decide whether I should go left or right, or straight forward, go straight on. So there are three, let's say, rules that can be applied. At the same time, I have to find a way of selecting one of them. So that's what conflict resolution is all about. So we select a rule and then apply that selected rule. And if new facts are obtained, As a consequence of firing this rule, then add them to the working memory. Okay, so what have we done? First of all, we've done the matching part. Then we have selected a rule to be applied and using conflict resolution. And then we apply that particular rule. And what are the consequences? If the new facts are being asserted by that rule, do it. Add them to the working memory. Now, the next step, step 4, stop or exit when the conclusion is added to the working memory. Or if there is a rule which states that you found the solution, stop. So that's when you stop and you have reached your conclusion. In the diagram, we have shown a structure of how things work. So as you can see, we have shown blocks of working memory, the inference engine, and then this matching part, okay, in the first row. As you can see, working memory, it has certain facts. You have inference engine, and then matching takes place. And then you determine possible rules to fire. That's the conflict resolution part. In the second row, you can see something called user. And that's the knowledge engine or the user who is actually placing facts in the working memory as well. You also have a rule base itself, which has rules, and that is interacting with the inference engine. So once the rules and the facts are actually matched through inference engine, you come to the determination of which rule to fire. So there's a set of rules, go to the conflict resolution strategy and select the rule to fire, as you can see with that diamond shaped thing. And from there, if you look at it, what will happen is that it'll either say that you have found a solution, or you can say you've not found a solution. If you've not found a solution, then you fire the rule, of course, go back to the working memory, or if you found a solution, you exit. So very briefly, this is how the structure works that I explained earlier on. Working memory, facts, inference engine, and conflict resolution. Let's look at a case study now for a practical example. Now, given a set of facts containing various information about flowers and given a set of rules, the task is to produce a solution, generate a solution, which indicates which flower is a white lily. A white lily. The objects or the linguistic variables and their possible values allowed by the expert system and contained in the database are shown in the table. So if you look at the table, the first column, it has a flower name, it has a season, it has a root type, life cycle, life type. These are those objects. And then the second column gives you the values against each of these. Remember, just like we said in the previous example, we had winter and the wind blowing. The wind blowing had, let's say, 2 or 3 conditions and so forth. Likewise, here we have flower names, several of them, then the season. Then we have another object called colors of those and several values against that. Okay. And then the size and perfume, like whether they have smell or not, and so forth. Then we have soil and height. So these are those particular objects along with their defined conditions or values that exist in the knowledge base. Okay. So our objective is to locate a white lily, right? And let's see how it works. The knowledge base contains several rules, and there are, in the knowledge system, there are 19 rules here. Okay, 19 rules. Rule 1, for instance, says that if the size of the flower is greater than 10 and it is less than 50, right? That's how rules are represented. It's like another way of saying if the size is between 10 and 50, okay, represented here as size greater than 10 and size less than 50, then we say that the height is small. Height, it's already given as an object with values in the database. So if the size is within this range, then the height is called small. Then we have another rule, rule 19. Okay, that's the closing rule, by the way. It says that if flower name is lily and it is perfumed, meaning the perfumed object has a true value, then the flower name is white lily. That's what the rule says. And if this rule executes, if this rule is fired, we will stop our search and we will say we've come to a conclusion. If this rule doesn't fire for a number of time, we keep on trying until we either say we found a solution or we haven't. So that's our closing condition. Remember the goal state we spoke about and initial states? So in one way, in other words, firing of rule 19 is like finding the goal state or the solution. So suppose we have the facts in the database. For instance, the season is spring, the root type is bulbs, the perfumed is true, and the size is between 16 and 18 centimeters. These are the facts I'm talking about. Then we have fact number 5, the life cycle, and the value there is more than 1 year. Another fact about color, as the colors are orange, red, white, and pink. These are the facts that we already know about. Now, we wish to infer the white lily flower using the 19 rules that we have. We go through 3 cycles of the Reti algorithm and see if we can reach the solution or not. Right. Cycle 1, matching. Now, rule 1 and rule 6 are applicable at this point in time. Rule 1 and rule 6 are applicable. The next step was rule selection. Remember? Conflict resolution, since there are 2 rules to be matched. Okay, so what we do is we select rule number 1 and we apply that rule. Rule application, what it says? If whatever condition, then height is small. So it looks at the height. If it is between 10 and 50, then you assert a fact called height is small. So this fact will also be added to the existing facts already in the working memory. Height is small. Again, matching. The rule 1 and 6 still applicable. But the rule selection says you can only select rule 6 since rule 1 has already been fired. So you apply rule 6 and a fact life type perennial. That's the consequence of rule 6. The life type perennial will be added to the working memory. Now the working memory has got 8 facts. Number 1, fact 1, season is spring, root type bulbs, perfumed true, size 16 to 18. These were given fact, the first 4. Then life cycle, more than 1 year, and fact 6 was color, values like orange, red, white, pink. Fact 7 has been now, so out of fact 6, these were the initial facts. Fact 7 has been asserted, height small. Fact 8, life type perennial. So 2 rules fired, 2 new facts added. Let's go follow through the second cycle. In this case, rule 1, 6, 10, 12, and 14 are applicable. 1, 6, 10, 12, and 14 are applicable. That's the cycle 2 matching. Rule selection. We can only select rule 10, 12, or 14 since 1 and 6 have already fired, have been executed. So let's select rule 10. We apply the rule. A fact, called fact 9, flower name is freesia, will be added to the working memory. 1 fact added by this rule. So working memory now has 9 facts. Match again. Rule 1, 6, 10, 12, and 14 are applicable. Okay, rule selection, conflict, resolution. We can only select rule 12 or 14 since 1, 6, and 10 have already been executed or fired. Let's select rule 12. So we apply the rule and a new fact is asserted. I call it fact 10. Flower name is Narcissus. This is added to the working memory, which now has a total of 10 facts, right? 6 were the initial facts and 4 facts asserted by the execution of these rules. Match again. 1, 6, 10, 12, and 14 are applicable. Conflict resolution. Select a rule. We can only select rule 14 since all others have already been fired, executed. So we select rule 14. And rule application meaning apply this rule. It asserts a fact, F11 I call it. Flower name is Lily, added to the working memory. Flower name is Lily, that's added to the working memory. So now the working memory has 11 facts about season being spring, root type bulbs, perfumed true, size 16 to 18, life cycle more than 1 year. I'm just repeating these. Color orange, red, white, pink, height small, life type perennial, flower name freesia, narcissus, and lily. These facts have now been added to the working memory. Now let's carry out a third cycle of this Reti algorithm. Matching again. We see rule 1, 6, 10, 12, 14, and now rule 19 is also applicable. Since rule 19 has been matched, rule selection criteria, I think you can now guess. We can only apply rule 19 since all other rules have already been fired. So we choose it, select it, fire the rule. And this application of firing of the rule adds a fact, I call it fact 15. Flower name is white lily, added to the working memory. Since this is also the goal, and the inference process will actually stop, and this is what it is. So what we've done is we have demonstrated the working model of a number of facts and rules. What we have done is we have applied the Reti algorithm to actually execute and come to a conclusion, right? So you match the facts and the rules. If there are more than one, you have got to do rule selection, which is conflict resolution, okay? And then you execute the rule. That's what it is, as simple as that. So let me just, before I close up, what I said before, rule-based systems or expert systems or production systems are very intuitive, okay? If this condition, perform this action. If these two conditions, perform this action. If these three conditions, perform this action until you reach a goal. If we didn't have rule 19, maybe we would never find that. But in most systems, that's how you design them. You need to have a closing rule or a fact that tells you that you found a solution. So I hope you found it interesting. We will see you next time. Thank you very much.